Hi friends, in this video we are going to solve the system of equation. Here number of equations are 1, 2, 3 and number of unknowns are that is x1, x2 and x3. So here we are going to solve this system of equation with the help of Gauss Jacobi iterative method. Here in Gauss Jacobi iterative method, first we have to check whether the given system is diagonally dominant or not. So that is my first task. Here what is meant by diagonally dominant? Here you can observe. So the coefficient matrix of this system is here. I will write. So here this is the coefficient matrix of this system is here 10, 1, 1. This is 2, 10, 1. This is 2, 2 and 10. So here this is the A11 position. Here what is meant by diagonally dominant? Here mod of A11, absolute value of mod of A11 is strictly greater than mod of A12 plus mod of A13. Now corresponding to row 2, mod of A22 strictly greater than mod of A21 plus mod of A23. Now corresponding to the third row, mod of A33 is strictly greater than mod of A31 plus mod of A32. Here this is my A11 position, A12 position, A13. Now here you can observe A11, that is here, I will write here. A11 means 10, strictly greater than. A12 means 1, plus A13 means 1. Now come to here second row, A22 is this 10, strictly greater than A21. This is A21 position and this is A23 position, that is 2 plus 1. Now come to the here third row. Here A33 position is this 10. Mod of A33 strictly greater than A31, that is mod 2 plus A32, that is this 2. So here you can check mod of 10 is 10. 10 is strictly greater than mod of 1 plus 1. The mod of 1 plus 1, that is 1 plus 1 is 2. So this is equal to 2. Here you can observe 10 is strictly greater than 2, 10 is strictly greater than 3 and 10 is strictly greater than 4. So here this means that my given system is diagonally dominant. Here don't write this. In the solution, here my system is checked. First step is system is diagonally dominant. So diagonally dominant, that is mod of 10 strictly greater than, that is A11 strictly greater than A12 plus A13 position. So this is simply one. Now come to here mod of 10, that is this A22 strictly greater than A21, that is 2 plus A23, that is. Now come to here third equation, mod of A33 strictly greater than A31 plus A32, that is 2 plus 2. Here since 10 is strictly greater than, that is here I will write this 10 is strictly greater than 2, this 10 is strictly greater than 3, this 10 is strictly greater than 4. So here our given system is diagonally dominant. Now second step, now we have to rewrite this given system of equation in terms of x1 corresponding to first equation. Here I will write 10 times x1 equal to 12 minus x2 minus x3. So here can I write this as x1 equal to 1 by 10 times 12 minus x2 minus x3. So in the same way, write equation 2 in terms of x2. Can I write here directly x2 equal to 1 by 10 times, here x2 equal to 1 by 10 times 2x 13 minus, this is 13 minus 2x1 minus x3. Now write in terms of x3 corresponding to equation 3, that is x3 equal to 1 by 10 times 14 minus here 2x1 minus 2x2. Here, this is the rewritten form of my system of equation. Here, I write this just for your sake of understanding. Here, how I am writing in terms of x1, x2, and x3. Here, I will write rewritten form. Rewrite system as. Here, this is the rewritten form of my system of equation. Here, x1 is equal to 1 by 10 times 12 minus. I will take this part as right hand side. So in terms of equation 2, this is in terms of equation 3. Now in the third step, take the initial guess. That is here initial guess. Here initial guess is start as x1 at 0 is 0, x2 at 0 is 0, and x3 at 0 is 0. So this is my initial guess. That is x1 at 0, 0, x2 at 0, 0, x3 at 0, 0. Now I want to find my first iteration. So I want to find my first iteration, that is x1 at 1, x2 at 1, and x3 at 1. So while finding x1 at 1, x2 at 1, x3 at 1, now we have to use this. I will use this x1 at 0, x2 at 0, and x3 at 0. So while finding x1 at 1, you use here x2 at 0 and x3 at 0. You use this both. So while finding x1 at 1, you are using x2 at 0 and x3 at 0. While finding x2 at 1, here I am using this. Here x2 at 1, here I am using x1 at 0 and x3 at 0. So here, while finding x2 at 1, I am using x1 at 0 and x2 at 0. So while finding x3 at 1, here I will use here x1 at 0 and x2 at 0. This is the concept here. Here, this is my first iteration. I will find this my first iteration with the help of x1 at 0, x2 at 0, x3 at 0. So here, while finding x1 at 1, I will use x2 at 0 and x3 at 0. So I will use this. While finding x2 at 1, I will use x1 at 0 and x3 at 0, which is given here. While finding x3 at 1, I will use this x1 at 0 and x3 at 1. Here that is x1 here. Here I will write here with the help of this here iteration 1. Iteration 1 here x1 at 1. X1 at 1. Here I will write by using this equation 1 by 10 times 12 minus. Here 12 minus. Here while finding x1 at 1, I will use x2 at 0 and x3 at 0. So here I will write x2 at 0 minus this is x3 at 0. x3 at 0. So here I know this value 1 by 10 times. Here I will write which is equal to 1 by 10 times here 12 minus x2 at 0 is 0, x3 at 0 is 0, which is equal to 12 by 10, which is equal to 1.2. Done. Now, while finding x1, x2 at 1, so here I will rub this. Here, while finding x2 at 1, while finding x2 at 1, here can I write here 1 by 10 times 13 minus here 2 times x1 at 0 minus here x3 at 0. So here just put here value 1 by 10 times here 13 minus 2 times x1 at 0 is 0 and x3 at 0 is 0 here, which is equal to here 0 0, which is equal to 13 by 10, which is equal to 1.3. Now, while finding x3 at 1, here x3 at 1, I will use x3 at 1, I will use x1 at 0 and x2 at 0. So I will write with the help of this 1 by 10 times 14 minus here 2 times x1 at 0 minus 2 times x2 at 0, 2 times x2 at 0 which is equal to, here just put the value 1 by 10 times here 14 minus here 2 times x1 at 0 0, 2 times x2 at 0 0, which is equal to, here this is 0, this is 0, this is simply 14 by 10, which is equal to 1.4. Now here we can observe this is my first iteration, that is here x1 at 1, x2 at 1 and x3 at 1, which is equal to, here x1 at 1 is 1.2, x2 at 1 is 1.3 and x3 at 1 is 1.4. So here you can observe this solution is approximately equal to, here 1.2 is approximately equal to 1, 1.3 is approximately equal to 1, 1.4 is approximately equal to 1. Here just for the sake of understanding, here I am writing. Now, so this is my, here I will write here. Now this is my, this is x1 at 1. Here I will write here. Don't write this. x1 at 1, x2 at 1 and x3 at 1. Here I found this x1 at 1, x2 at 1 and x3 at 1 with the help of x1 at 0, x2 at 0 and x3 at 0. So here I find this value x1 at 1, x2 at 1. So here I will write here 1.2, 1.3, 1.4. Here I find this value with the help of x1 at 0, x2 at 0 and x3 at 0, which is given approximately equal to 0, 0, 0. Now while finding x1 at 2, x2 at 2 and x3 at 2, here while finding x1 at 2 I will use this pair. So here while finding x1 at 2, so while finding x2 at 2, x2 at 2 I will use this, x1 at 3, while finding x3 at 2, while finding x3 at 2, here while finding x3 at 2 I will use this, here again I will use this. So here that is the way. Here I will write again, here while finding x1 at 2. So here while finding x1 at 2 I will use x2 at 1 and x3 at 1. I will write in terms of here 1 by 10 times here 12 minus here x2 at 1 minus x3 at 1. Then here which is equal to 1 by 10 times 12 minus x2 at 1 is x2 at 1, that is 1.3 and x3 at 1 is 1.4. Now which is equal to 1 by 10 times here 12 minus here 1.3 minus 1.4, that is 2.7 here, which is equal to here x1 at 2. So x1 at 2 means, so you can just calculate here 0.93. So here 0.9. So here you can just calculate 0.93. So here just 12 minus, here I will calculate 12 minus 0, that is 2.7. Here 10 minus, this is 3, this is 11 minus 2, 9. So here 9.3 divided by 10, which is equal to 0.93. So this is my x1 at 2. Now I want to find here x2 at 2. So while finding x2 at 2, which is equal to 1 by 10 times, here 1 by 10 times 13 minus 30. While finding x2 at 2, I will use x1 at 1 and x3 at 1. Here x2 at 2, 1 by 10 times 13 minus here 2 times x1 at 1 minus x3 at 1. Now which is equal to 1 by 10 times here, this is 13 minus 2 times x1 at 1 is given 1.2. This is 2 times 1.2 minus x3 at 1, that is 1.4 here, which is equal to 1 by 10 times here 13 minus here 2.4, this is 2.4 minus 1.4, 2.4 minus 1.4. Now this is equal to, here I will write here 1 by 10 times here 13 minus here, this is 2.4, 1.4, this is 3.8. Here you just subtract this 13.0, this is 3.8. Subtraction 10 minus 8, this is 2. Here 12 minus 3, this is 9.2. Here which is equal to 9.2 divided by 10, which is equal to 0.92. So here this is my x1 at 2. Now find the x3 at 3, which is equal to 1 by 10 times here 14 minus 2 times x1 at 2. X3 at 2. This is 2 times x1 at 1 minus here 2 times x2 at 1, which is equal to here 1 by 10 times 14 minus here 2 times x1 at 1 is 1.2 minus 2 times x2 at 1, that is 1.3. Here I will write here, this is equal to 1 by 10 times here 14 minus, this is 2.4 minus, this is 2.6. Here 2.4 minus 2.6, which is equal to, can write here 1 by 10 times here 14 minus, here can I write this as simply 3. So this is 2.4 minus 2.6, here directly 5. So this is 5. So which is equal to, here I will write here, which is equal to 9 divided by 10, which is equal to 0.9. So this is my x2 at 2. Now here I got here x1 at 2, x2 at 2 and x3 at 2, which is equal to, here x1 at 2 is, this is 0.93, x2 at 2 is 0.92 and x3 at 2 is 0.9. So this is my second iteration, second approximate solution of the given system of equation. Now I want to find third iteration, that is x1 at 3. So here while finding x1 at 3, I will use x2 at 2 and x3 at 2. So while finding x2 at 3, I will use this x1 at 2. Here I will write x1 at 3, x2 at 3 and x3 at 3. I want to find this. So while finding x1 at 3, I will use this pair, x2 at 2 and x3 at 2. While finding x2 at 3, I will use this x1 at 2 and x3 at 2. So while finding x3 at 3, I will use this x1 at 2 and x3 at 2. So x2 at 2, that is the way. Now this is my second approximate solution. So here also you can observe one thing, 0.93, which is approximately equal to 1, 0.92, which is also approximately equal to 1, and 0.9, which is also approximately equal to 1. So here this is the approximate solution of this given system of equation after. So this is my second iteration. Now I want to find the third iteration, that is here I want to find here iteration 3 with the help of this x1 at 2, x2 at 2 and x3 at 2. Here I want to find x1 at 3. So this is equal to 1 by 10 times here 12 minus x2 at 2 minus x3 at 2. So here which is equal to 1 by 10 times here 12 minus x2 at 2 is 0.92, x3 at 2 is 0. Let's say 90. So which is equal to here, tell me here, this is 1 by 10 times here 12 minus here 0.92 minus 0.90, that is 2 9 9 18 18, that is 1.82. So here 12 minus 1.82, here I will calculate here 12, that is 0, 1.82. So this is minus here 10, this 8 9 1, this is 0 and this is 1, that is 1.18. So here this is equal to, I will write here which is equal to 1 by 10 times here 10.18, which is equal to 1.018. So here this is my x1 at 3. Now calculate x2 at 3, which is equal to 1 by 10 times here 1 by 10 times 13 minus 2x1, that is 2x1 at 2 times x1 at 2 minus x3 at 2, that is x3 at 2. So here which is equal to here 1 by 10 times here 13 minus here 2 times x1 at 2 is x1 at 2, that is 0.93 minus x3, that is x3 at 2 is 0.90. Now here from here I will write here 1 by 10 times here 13 minus 2 times, that is 6 18 1.86 minus, that is 0.90. Here which is equal to 1 by 10 times here 13 minus here 6 7 2.76, which is equal to, now here just find here 13 2.76, that is minus 10 minus 6, that is 4, 9 minus 2, this is 0 1 point, here I will write 10.24 divided by 10, which is equal to 1.024. Now find x3 at 3. Now I want to find x3 at 3, which is equal to 1 by 10 times here 14 minus here 14 minus 2 times x1 at 2 minus 2 times x3 at 2, which is equal to 1 by 10 times here 14 minus 2 times x1 at 2 is x1 at 2, that is 0.93 minus 2 times x3 at 2, x3 at 2, that is this one, that is 2 times 0.9, this is 2 here. So here from here I will write here, I don't have space, 1 by 10 times here 14 minus, this is 1.86 minus, this is 1.84, which is equal to here 1 by 10 times here 14 minus, can I write this is 1.86 minus 1.84, here I will write this is equal to 6 to the 640 17, and this is 2 and 3.70. So here this is equal to, here calculate, I will calculate here 14.00 3.70, here subtraction, this is 0, this is 3, this is 0, this is 1. So here 10.30 here, which is equal to 10.30 whole divided by 10, which is equal to 1.030. So this is my third iteration. So here after that I will write here. So here from here to here I will write again third iteration. So here, from here, I will write here x1 add 3, comma x2 add 3, comma x3 add 3. That is my third iteration. Here x1 add 3 is 1.018 and x2 add 3, that is 1.024 and comma x3 add 3, that is 1.030. So this is my third iteration. Now here in the starting itself, so you can observe one thing, this solution is also approximately equal to, here 1.018 is approximately equal to 1, 1.024, that is also approximately equal to 1. In the same way 1.030, this is also approximately equal to 1. So here you can go up to fourth iteration also. Here with the help of this, so similarly you can find similarly x1 at 4. So x1 at 4. So you have to calculate x1 at 4 by using x2 at 3 and x3 at 3. So here after finding the calculation, you will get here, I will write direct solution. So which is equal to 0. Here I have calculated value 0.9946, which is also approximately equal to 1. In the same way, x2 at 4 you can calculate, which is also you can calculate by using x1 at 3 and x3 at 3. You will get 0.9934, which is also approximately equal to 1. And in the same way, x3 at 4, that is your fourth iteration, you will get 0.9916. So here this is also approximately equal to 1. So here in the starting, we check whether the given system is diagonally dominant or not. After that, rewrite the system in the form of x1 corresponding to equation 1, in terms of x2 corresponding to equation 2, in terms of x3 corresponding to equation 3. After that, find the initial case x1 at 0, x2 at 0, x3 at 0 is 0. After that, find the first iteration, second iteration, third iteration. So in the way, this is my fourth iteration. So here fourth iteration I am finding by using, this is my third iteration. So here in the same way you can go for fifth iteration also. But here I observe one thing. So at second iteration onwards, that is this is my second iteration, this is my third iteration. So you can observe one thing, the difference is not big. Here the difference x14 minus x13. Here this is my x14 0.9946 and this is my x13 1.018. That difference is not large. So that difference is, here I am saying that difference xi at k plus 1 here minus xi at k. That difference is here which is less than epsilon. Here we can take epsilon as 10 power minus 3 or we can take 10 power minus 4. So that's why here after third iteration the difference is not big. So by previous iteration or next iteration, that's why you can stop after 3 or 4 iteration most of the time in your theory exam. So after that, at last write the statement as the approximate solution of given system is, here I am writing x1 which is approximately equal to 1, x2 which is approximately equal to again 1 and x3 which is approximately again equal to 1. So this is my final answer. So whenever someone asks find the solution of the given system by using Gauss Jacobi iterative method, so you can go up to 3 or up to 4 or 5 iterations. So after that you can conclude your answer by approximate answer. So tell here this is 0.9946 which is approximately equal to 1. So this is 0.9934, this is 0.9916, this is also approximately equal to 1. So at the end you can tell the approximate solution of the given system is x1 is 1, x2 is 1 and x3 is 1. Thank you.